we want to solve 2ix squared plus root 8x take away root 3 equals 0, either by using the quadratic formula or by completing the square. I'm going to use the formula here. A is equal to 2i, b is equal to root 8, c equals negative root 3. We know that x is going to be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's going to be negative root 8 plus or minus the square root of 8 take away 4 multiplied by 2i multiplied by negative root 3 all over 4i. So that's negative root 8 plus or minus the square root of 8 plus 8 root 3 I all over 4i. So before we can go on, we need the square root of 8 plus 8 root 3i. So let's think about that one. 8 plus 8 root 3i is up here, and this is 8, and this will be 8 root 3. So this angle here, we should see straight away, is pi by 3. And then we've got 64, and we square 8, and this one's 64 times 3, which is 192. So we want the square root of that. That's the square root of 256, which is 16. So we can see that that's 16 cis pi by 3. Now if we just go for the first root of that, that's going to be 4 cis pi by 6. So let's think about that one. So that's going to be, it's going to be here. There'll be another one down there, but that's just the negative, so that's why we don't need to worry about finding both of them. So we're going to have 4 cos pi by 6 plus 4i sine pi by 6. Cos pi by 6 is root 3 over 2, so this one is 2 root 3. And sine pi by 6 is a half plus 2i. So what we have is negative root 8 plus or minus 2 root 3 plus 2i all over 4i. Now multiply top and bottom by I, so the bottom's going to give us negative 4. Then I've got negative root 8i plus or minus 2 root 3i take away 2. So that's negative root 8i plus 2 root 3i minus 2 over 4. And the other solution is negative root 8i take away 2 root 3i plus 2 over 4. So we're going to have negative 2 plus 2 root 3 take away root 8 I over 4, and then we'll have 2 take away 2 root 3 plus root 8 I over 4. And the point is, these are not conjugate. So what we've seen in the last few examples are that when the coefficients a, b, and c are real, we get a conjugate pair of solutions. But when any of the coefficients are not real, we don't get conjugate roots.